Hello students, today we are starting our first chapter from the geography, which is interpretation of the topographical maps. So the first question which arises in front of us is, what is a map? A map can be defined as, a map is a representation of Earth's surface or a part of it showing natural and man-made features drawn to scale on a flat surface. We can now see different maps on your screen. One of them is a political map of India, other one is a railways map of India. So these various maps represent a portion of the world which is India, and they are representing any one of the geographical factor related to India. Now we are going to classify these maps. Maps are broadly classified into two types: large-scale maps and small-scale maps. Large-scale maps are used for representation of a smaller area, and obviously small-scale maps are used for representing a larger area on a very small piece of paper. The example of large-scale map is a topographical map, which the sample of which I am showing on the screen. And the example of small-scale map, there are many examples of small-scale map, and the best example is the political map of India or railways map of India. These are good examples of small scale map, as India is a fairly large country and the entire country of India is shown on a very small piece of paper. So such maps are called as small scale maps. We are going to study in detail about scales of the map, but now we will continue with the topographical maps. First point is history of topographical maps or history of topo maps. An organization named Survey of India was formed by the Britishers. This organization is one of the oldest organization which is still working in India. So this organization, that is the Survey of India, they divided Indian subcontinent, that is India, Afghanistan, China, Myanmar, Bangladesh, Nepal, these countries into one, and as well as the surrounding regions of Afghanistan, China, Iran, into 137 divisions. They only divided the land part of this region, and the maps of these 137 regions were prepared. They were named, they were given numbers from 1 to 137. The scale of these maps are 1:1 million, that is 1:10 lakh. Therefore these maps are also called as million sheets. Further, each one of them means each one of the 137 maps were further divided into 16 more divisions, and they were given names as A to P, and the scale of these maps were 1:250,000, and further these quarter sheets, these sheets were also called as quarter sheets. These quarter sheets were further divided into 16 parts and given numbers 1 to 16, and the scale of these maps were 1:50,000. So in this way the entire country of India is divided. So whenever I will say 45D7, that is map 45D7, it means that it is the 45th map. It is the 45th map of India. Means India, the entire country of India, is divided into 137 parts, and out of which I am concerned about 45th part or 45th map. This 45th map is further divided into 16 parts named A to P, and out of which I am observing D map. Means D part of the 45th map, and this D part is further divided into 16 more parts named 1 to 16, and out of which the map we are observing is the 7th one. So this is the meaning of 45D7, or 45D10 means it is the 10th part of the 45D map. These are the two maps that we are going to study in this year. Topographical maps are detailed maps of a very small region. Therefore, they show us physical as well as man-made features. They show physical features such as valleys, hills, peaks, rivers, and water bodies, as well as man-made features such as roads, railways, bridges, buildings, railway stations. To depict physical features, we generally use contour lines. And to depict man-made features, we have conventional signs and symbols. We will see both of these, that is contours as well as signs and symbols, in this lecture. To show physical features in a topographical map, we use three methods. One is hatch lines, second is hill shading, and third is contour lines. The first one is hatch lines. In hatch lines, by using hatch lines, we can show the slope of a land. If the slope is steep, we use very smaller hatch lines, and if the slope is gentle, we use longer hatch line. As you can see, a hill is shown with the help of hatch lines in the diagram. You can see that slope at the top of the hill is very steep, and it is shown with the smaller hatch lines, whereas slope in the base of the hill is bit gentle, therefore it is shown with the very longer hatch lines. The next method of showing physical features is hill shading. In this method, different shades are used to show the slopes of the hill, as you can see in the diagram. The next method of representing physical features is contour lines, and this method is most widely used in our maps. So what are contour lines? Contour lines are imaginary lines joining places which have the same height above the sea level. The contour lines are generally brown in color, and there are two types of contour lines: thick contour lines and thin contour lines. Thick contour lines generally have a contour interval of 100 meters, and thin contour lines generally have a contour interval of 20 meters. Now, with the help of this diagram, we will see how the contour lines represent physical features on a map. We can see a conical hill. In the figure, you can see that there is a conical hill, and the conical hill is present on the ground, and how this conical hill is represented with the help of contour lines on a map. So the representation which you are seeing above is the representation on the map, which is two-dimensional representation, and the representation you can see below is the actual hill which is present on the ground. In this way, the three-dimensional features like hills, plateaus, waterfalls, or many physical features which are three-dimensional features and which cannot be represented on a two-dimensional or a plane map, can be easily represented by using certain lines, or by using contour lines. This task of representing three-dimensional features becomes very easy. We have to solve many questions depending on the contour lines, and we also come to know many features about the land by using contour lines, that we are going to see. So the other ways of representing height in a topographical maps are spot height, triangulated height, relative height, and benchmark. First one is spot height. As you can see on the screen, a point with the number 500 is shown. This point indicates that the height of a particular point or particular place in a map from the mean sea level is 500 meters. In the next on the screen, you can see a triangle with the number 340. This way of indicating height is called as triangulated height. In triangulated height, we measure height of peaks by using trigonometry, and this height of peak is not from the mean sea level, it is from the base of the peak. That is, this sign indicates that from the base of the peak, the height of the peak is 340 meters. Another way is a relative height. You can see on the screen 3R with a dot. This method of indicating height is generally used to represent the embankments of the river. This way is used to compare the maximum and minimum heights of a region. The 3R written represents that this point is 3 meters high than the minimum point of that region. And the last method is benchmark. These benchmarks are generally placed in a region to help cartographers or to help map makers to find the heights of the various places. Another visible part in the topographical map is a drainage pattern or drainage system. The water which falls in the form of precipitation on any part of land flows into the sea. First it gets collected, the water which is fallen in the form of rainfall first get collected in the form of streams, and these streams flow into larger streams, then into rivers, and then these rivers meet the sea. In this way, the water which has fallen on the ground drains. And how this drainage take place, or what is the pattern of this what is the pattern of the flow of this water, that we have to see in this part. So there are 3 different patterns, or you can say 4 different patterns of drainage which are generally found. The first is dendritic drainage. Dendritic drainage, in this part, the water flows like branches of the tree. You can easily observe it in the diagram. The next type of drainage is trellised drainage. In this part, the smaller stream meet the larger stream, making a right angle. Therefore, a rectangular pattern is generally formed. Next type of drainage is a radial drainage. In this type, streams flow in a circular pattern, or they flow like the directions of the wheel, of the spokes of the wheel. You can easily observe it in a diagram. The next type of drainage is underground drainage. The underground drainage is not seen on the ground. This takes place in the dry regions. This type of drainage takes place in the dry regions and generally shown with the dotted black lines.